Hello, in this discussion we'll be talking about the length of an arc of a circle. All right, let's begin. So if you look at this circle, and S in S1 are basically this part of the circumference of a circle. So when you're talking about the length of an arc, you're talking about a portion of the circumference, not the whole circumference. Remember, the circumference is the distance all the way around the circle, and that was what we were interested in a geometry class. We were interested in the distance all the way around the circle. Well, in this course, we may not be interested in that whole circumference. We're maybe just interested in the distance around portion of the circle based on the theta. So one thing I wanted to show you is that if you take two circles that have different angles, so theta and theta sub r, and you take that ratio theta divided by theta sub r, then that's going to be equal to the same ratio of the s and the s sub 1s. And so that comparison, you can actually do a cross product here and make another direct relationship between those two. But what we're going to do is we're going to tail off of that a little bit and talk about the arc length in particular. And it says, for a circle of radius r, a central angle of theta radians subtends an arc whose length s is s equals r times theta. Now, S equals R times theta is the formula for the length of an arc of a circle. Now, theta has to be measured in radians. Notice what that last part right there says, theta radians. It didn't say theta degrees, so your angle has to be in radians. Now, let's backtrack a little bit. You remember we talked about radians in the last video. Now, radians is the way to measure an angle another way. Now, one thing we need to discuss is the one revolution. One revolution in degrees is 360 degrees. But in radian measure, it's 2 pi radians. 2 pi is the same thing as 360 degrees. So what's pi? Well, pi is that 3.14 that you're full aware of. So approximately 6.28 radians, 3.14 times 2, is one revolution. Simply put, just 2 pi. Okay? Now look at this formula right here. What if theta was 2 pi? Well, if theta was one revolution, you're talking about the whole circumference. So if theta was 2 pi, well, then what's r times 2 pi? Written another way, it's 2 pi r. And that formula should be familiar to you. So r times theta, r times 2 pi r is the circumference. But in this case, it's just taking the circumference formula, and we're not having 2 pi r, we're having whatever the theta is. Maybe the theta is just going to be 1 pi, which is a half of a revolution, and then is pi times r, depending on what the radius of that circle is. So theta has to be given to you in radians, and if it's not, you have to convert it to radians. We'll learn how to do that as well. We haven't done that yet. So that is the formula for arc length. Now, we're also going to be giving you a table soon of conversions between degrees to radians and a formula for that, and just basically a table of conversion for that. All right? But before we do that, I want to give you an example here. It says, find the length of an arc of a circle. So find the length of an arc of a circle of radius 4 meters, subtended by a central angle of a half of a radian. Now you're like, what is 0.5 radians? Remember, 1 radian was about 57, 58 degrees. So a half of a radian is around 27, 28, 29 degrees. So a half of a radian is around 28 degrees, 29 degrees maybe. So that gives you an idea of what kind of an angle you're dealing with. So you have a circle, you have 2 radii, and the radii has an angle that's formed of about 28, 29 degrees, and you want to know what the length of that arc is. So it's just a matter of substituting those numbers into the formula. S equals r times theta. It's 4 is the radius, and 0.5 is the angle. Notice it's in radians, so it gives you a distance of 2 meters. So it's an arc that's 2 meters long. Now what we're going to do is convert from degrees to radians, from radians to degrees. Okay, now like I said, we're going to be using this formula here. Okay, 1 revolution is 2 pi radians. So now read like, well, why is that? Well, 360 degrees is 1 revolution as well in degrees. Now remember, it was 57 degrees was 1 radian. Well, 2 radians and 3 radians. So 3 radians would make me 3 times 57, which is about 171, 172 degrees. So 3 radians is around 171, 172 degrees. Well, if you go an extra 8 degrees or so, that's that extra 0.14. So that's 3.14, also known as pi radians. So 1/2 of a revolution is pi radians. If you double that, that's 1 revolution, but that's pi times 2, which is 2 pi radians. Now that's a way to think about it, but you just got to remember 360 degrees is the same thing as 2 pi radians. You remember that, you're good to go here. So, alrighty. So there it is. 180 degrees is 1 pi radians. So 1 degree is pi over 80 radians, and 1 radian is 180 over pi degrees. And those are your conversion formulas. So to go from to degrees to radians, you need to multiply by pi over 180. And to go from radians to degrees, you'll need to multiply by 180 over pi. And let's give you some examples of those. So convert each angle in degrees to radians. So 80 degrees, you multiply that by pi over 180, which is 80 pi over 180. Reduce it down to 4 pi over 9. Part B, 140 degrees is 140 times pi over 180, which is 140 pi over 180, which reduces down to 7 pi over 9. So that's 7/9 of a pi. Now think about pi. Pi is half of a revolution. 7/9 of a pi is, well, it's 7/9 of half of a revolution. So you end up in the second quadrant. So 7 pi over 9. Now negative 30 degrees is negative 30 times pi over 180. And that reduces to negative pi over 6. And then D, 100 degrees is 100 times pi over 180, which is 100 pi over 180, which is 5 pi over 9, which is a little bit more than half. So that ends up in the second quadrant as well. The biggest thing that people have trouble with is why? Why do we need another way to measure angles? Degrees always have worked for us in the past. Why do we need another way? Well, not to mention reasons that you don't understand why in calculus. But one more basic reason why you would want to convert it to radians in terms of pi's is large angles. Think about an angle that goes, you remember the terminal side doesn't have to end before 1 revolution. You can have an angle that goes around 12 times or 13 times and end up somewhere in the third quadrant somewhere. And that's going to be a huge angle if you go around multiple times. So for example, if you go 1 revolution, that's 360 degrees. You go another revolution, that's 720 degrees. You go around again, that's over, 1,080 degrees. So it's getting kind of difficult to even add those numbers up in my head. And then after 1,080, well, if I go a 4th revolution, well, then you got to get 1,080 and add 360. And if you can't do that in your head, you'd be pulling out your calculator. But in radians, you won't need to do that, because if you go 1 revolution, that's 2 pi. Go another revolution, that's 4 pi. Go another revolution, that's 6 pi. Go another revolution, that's 8 pi. So you're adding smaller numbers. So for large angles, radians works a lot better because of the multiple revolutions that you use. So you don't have to deal with those large 3 and 4 digit numbers sometime when you're discussing degrees. So that's the advantages at this level. There are bigger advantages of radians as far as degrees in other fields like calculus. So, okay. Now we're going to go from radians back to degrees. Now, a lot of these angles here, you're going to have a table that converts one to the other, and just to kind of look at the table. But a lot of times that table is not available, and so you want to wait another way to measure in degrees. So 2 pi over 3, at this point in time, a lot of you guys may not know what that angle is. You can't form that angle in your head. But if I told you the angle was 120 degrees, everybody could tell me, yeah, that's in the second quadrant. It's more than 90, but it's less than 180, so it's a 120 degree angle. So you know where that terminal side is going to end up at. You know it's going to end up somewhere in the second quadrant. But if I gave the angle as 2 pi over 3, maybe not so much. So it's kind of like learning a new language, okay? If somebody speaks to you in another language, the first thing you do is you'd have to translate it to your native language. And so, but if you're fluent in both languages, you don't need to do that translation. So a lot of people are fluent in both Spanish and English. And so if somebody speaks to them in English, they don't necessarily translate that to Spanish, and vice versa. But if somebody's just learning the Spanish language, just picked up the book and started learning the language itself, the first thing they do is when somebody says something to them in Spanish, they first get that dictionary out and look to see what that meant in English. Okay, so that's kind of what you're doing here. You're learning a new language. You're learning radians, and 2 pi over 3 isn't right now. Might be a little different, a different language for you. So this is what the purpose of this for is. So 2 pi over 3 times 180 over pi. The pi's cancel, and you get 360 over 3, which is 120 degrees. So there it is. Now b, 5 pi over 6, multiply it by 180 over pi. The pi's cancel. You get 900 over 6, which reduces down to 150 degrees. Also a second quadrant angle. Negative 3 pi over 5, multiplied by 180 over pi, is negative 540, but the pi's cancel. Negative 108 degrees. Now remember, a negative angle goes clockwise. So this angle is going to end up in the third quadrant. So, because you're going clockwise. And then 8 pi over 3, multiply that by 180 over pi. You get 1,440 pi over 3 pi, and the pi's cancel again, and it's 480 degrees. So now that's a good analogy right there. Look at 480 degrees, a 3-digit angle. Now 8 pi over 3 may not look very nice to you, but it is just one small fraction compared to 480 degrees. So it has its advantages in a lot of ways. And then 2 radians, notice there's no pi on this one, but you still kind of do the same process. So it's 2 times 180 over pi. And then it'd be 360 over pi, and no pi's won't cancel. So here's where you do an approximation. So 360 divided by pi, which is 114.59 degrees. Now you're like, well, what about the minutes and seconds? Well, you can. You can take that 0.59 partial of a degree and convert it to minutes and seconds. It's not necessary unless they ask you to do it in a problem. So 114.59 is acceptable unless it says convert your final answer to minutes and seconds. And then you got to take, if you do that, then you got to take the 0.59 and times it by 60, and that'll tell you how many minutes, the leftovers, take that and multiply it by 60 again, and that'll tell you how many seconds. So, and here is the table I was referring to previously. It's a little conversion. It's a, so you can do what we just did, the convert, or you can just kind of look at this table. So if you have a 30-degree angle, that's the same thing as pi over 6. 90-degree angle is pi over 2. Oh goodness, remember the 150-degree angle? That was one of our previous examples. 150-degree angle, that's 5 pi over 6. So this is a good little thing to actually get down and just pause the video right here and just write these down and put them on your flashcard and memorize them. Okay, that way when you encounter a 4 pi over 3, for example, you can just look at this table and say, oh, it's 240 degrees. So otherwise you're going to take that 4 pi over 3 and you're going to have to multiply it by 180 over pi. So, and do your own conversion. So it does simplify things a little bit. Okay, and then we're going to find the distance between 2 cities. Okay, so the latitude of the location L is an angle formed by a ray drawn from the center of the Earth to the equator. A ray drawn from the center of Earth to L. Okay, see the figure in 13b. Here it is. All righty. So you got these two cities, which is due north of Albuquerque, New Mexico. Find the distance between these two cities. Now, they give you their latitudes. Now, the latitudes is basically the angle that's formed from a radius to the equator to another radius that's formed from the center of the earth to that particular city. That's what latitude is, okay? So one city, the Glasgow, is 48 degrees 9 minutes north. Albuquerque is 35 degrees and 5 minutes north latitude, but one, remember, is due north of the other. So what you need to do, you're going to assume that the radius of the earth is 3,960 miles, 3,960 miles. Now, what you have to do is figure out the angle between those two, since one's due north of the other. So what you got to do is take the difference of those angles. So one's 48 degrees 9 minutes, the other one is 35 degrees 5 minutes. So I think that's around 13 degrees 4 minutes. So we're going to find the distance between those two cities. This is where the S equals R times theta comes in, because that's the distance of that arc between those two cities. So there's your S equals R theta. But remember, theta has to be measured in radians in order to use this formula, but it's not. It is 13 degrees 4 minutes, yes, but it's not measured in the correct form. So you got to take that 13 degrees 4 minutes and multiply it by pi over 180. And then if you do that, it's 0.2281 radians. Now, I simplified myself a little bit. 13 degrees 4 minutes, you'd need to write that as a decimal first, and then multiply that by pi over 180, get to 0.2281. Then you take the 3960, which is the radius of the earth, and multiply by the theta, which is 0.2281 radians. And you can't multiply by 13.4. Now, a lot of people would. A lot of people would take the 3960 and multiply by 13.4. And you get like a 4 or 5 digit number. You'd be getting into tens of thousands of miles. So you can just tell by just look where the earth is listed, shown there, that those two cities are not, almost 100,000 miles apart. I mean, you go all the way around the earth. I mean, do you get 100,000 miles or do you go all the way around the earth? I don't think so. And so, but you take the 0.2281 and multiply by the 3960, you get 903.1 miles between those two cities. So, but it's very important to get that conversion done, okay? A lot of people will just multiply those numbers up and get the horrendous numbers. So, well, I used the formula because it said R times theta, but you didn't meet the restriction that theta is measured in radians. So you got to take that one extra step, is to do that conversion. All righty? So that concludes this video. If you have any questions on this one or anything else, you feel free to contact me, and you have a good day.